Hello everyone, Namaskar, Raj Krishna this side. So today we are going to solve this problem which is based on Newton forward interpolation formula. Now we have been given the data set which contains year and population in thousand. Now what we need to find is to estimate the population for the year 1896. So, based on the data set, we need to predict or estimate the population for the year 1896. Now, because this value 1896 is closer to 1891, which lies on the top of the data set. So, because it lies on the top of the data set, so we will use the Newton forward interpolation formula. Okay, because 1896 is closer to the first few data sets. I am talking about this are, let's say these are the values of x and these are the values of y. Okay, now what's next? So for using that Newton forward difference formula, what we need to find are these values which are delta, sorry, del y, which is the first difference. Okay, first forward difference. So how we find this is simple. 66 minus 46, so that will give you 20. Then let's use calculator so that we can use it, calculate it faster. There is no need of that in this because the values are not in decimals, but yes, we can use it to make our calculation faster. So 81 minus 66 will be the next one, which will give you 15. Then we will have 93 minus 81 giving us 12, and then finally 8. So this was the value of delta y. Let's find the value because there are 5 values, so we need to find till delta y, till 4 difference. That will be clear for you. Let's see. The second difference is del 2y. Now 15 minus 20 is minus 5. Write that in the middle of 20 and 15. 12 minus 15 is minus 3. 8 minus 12 is minus 4. Third difference, minus 3 minus minus 5, that is minus 3 plus 5, minus 4 minus minus 3, that means minus 4 plus 3, and this will be the last one because you are getting only one value now, minus 1 minus 2, which is minus 3, and you will stop here. Okay, so we stop here. So this tabular interpretation is clear for us. Now we can, which value we take as x naught, because 1891 is the closest to 1896. So taking this as x naught, let's use some other color so that it becomes clearer. So if you use this as x naught, this value becomes your y naught, and corresponding to that, these are our required value which we'll be focusing on. That's why I written it like this. So this will be your del first difference, del 2y naught, and this. Fine, clear? Now what's next will be the use of formula, but before that the components of formula, let's write that. So at first we have to find what is xp. So xp, as it is clear from the question only, estimate the population for the year 1896. So this will be your xp. Fine. So xp is x naught plus p times h. And what is h? The difference in x values, which is clear that it is 10. So h here is 10. So 1896 is x naught, which we have declared as 1891, plus p into 10. So we'll take the difference. So 5. So p value is 5 by 10, which is zero point 0.5. Okay, I found the p value and the other values which are there. Delta y naught, del y naught, again and again I said this delta. So del y naught, del 2 y naught, then the third difference and the fourth difference. Fine. Other values are that of x naught and that of y naught. Let's use the formula. So formula is yp, Newton forward difference formula. Yp is y naught plus p times del y naught plus p into p minus 1 divided by 2 del 2 y naught p minus 1, p minus 2, these are just binomial expansion, divided by 3 factorial, which I am writing as 6 clearly, del 3 y naught, and finally p minus 1, p minus 2, p minus 3 divided by 4 factorial, which is 24, del 4 y naught. Because the other values after this will be 0, so I will not be writing that. Okay, because del 5 y naught onwards is 0, so 0 multiplied by anything will give you 0. So now yp is what is the value of y naught? Y naught value is 46 plus p, which is 0.5 times first difference is 20 plus p into p minus 1. So p is 0.5 into 0.5 minus 1. So 0.5 minus 1 is minus 0.5. And what is the second difference? That is minus 5. Fine. Plus 0.5, 0.5 minus 1, 0.5 minus 2, and the third difference is 2. Next we have 0.5, 0.5 minus 1, 0.5 minus 2, 0.5 minus 3, fourth difference is minus 3, and so. So let's use now calculator to find the values. So we have 46 plus 0.5 into 20 plus 0.5 into minus of 0.5 divided by, okay, into minus 5 is also there. This divided by 2. Then next we have plus 0.5 into minus 0.5 into minus 1.5 into 2 divided by 6. Next we have plus 0.5 into minus 0.5 into 1.5 into minus 2.5 into minus 3 divided by 24, and this is giving you 56.632. Value slightly looking deviated from what I found. This happens in calculation sometimes. So 56.86 I found last time, and this time 56.63. Okay, what I will do is I will now calculate it like this: 46 plus 0.5 times 20. Now this is plus 0.5 into minus 0.5 into minus 5 divided by 2. What is the value? 56.625. Now I calculate the other two values. Zero 0.5 into and finally 2.5 into minus of 3 divided by 24. Now it is coming perfect. 56.867, and because it was in thousands, so we can write 1000. Now always do one thing. in case you have four values, let's say here. So find the first two or three values, then get the answer, and then to the answer add the next two values, so that you will get a better answer, or the answer which is given in the textbook. So this is it for today. Just the starting of this, we can have a few more problems and certain application like finding the polynomial from the given data set. So we'll solve that type of problem up next. So today it was basic. We need to estimate the population for the year 1896. So for that, the value closest to that was 1898, 1891, and that was on the top. So we use the Newton forward interpolation formula. Okay, so in the Newton forward interpolation formula or forward difference formula, we have certain things which we need to calculate. First, the difference table, then the value of p we need to calculate. Value of h is clear from the table, and then we need to apply the formula and get to our YP value, which came out to be 56.837 thousand. So that was the estimated population for the year 1896. So that's it for today. We'll see you with some more problem. You can watch this video in the playlist iterative techniques and interpolation. Thanks again.